Lesson 71, Making and Analyzing Scatter Plots. One type of graph that relates two sets of data with plotted ordered pairs is called a scatter plot. Scatter plots are considered discrete graphs because their points are separate and disconnected. Okay, that means we don't draw a line from one point to the next. Okay, they're disconnected. The points on scatter plots sometimes form a linear pattern. In these situations, a line can be drawn to model the pattern, which is called a trend line. Whenever we draw a line to model the pattern, we are not necessarily connecting all of the points. We're just drawing a line that best fits all of the data points. A trend line is a line on a scatter plot which shows a relationship between two sets of data. So for example 1 says graphing a scatter plot and a trend line. It wants us to use this table and make a scatter plot of the data, then draw a line on the scatter plot. So we're going to start by plotting on the graph. With the pen tool, come on. There we go. I have points 1 through 6 for x, so I'm going to label those across the x-axis, and I'm just going to go 1, 2, 3, 5, and 6. And I'll just draw these on here. Okay. Then I have numbers 4 through 29, which means that I need to cover 0 through 30. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could go by threes according to what we have here, so we will. So I have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, so now I'm going to plot each of my points. So my first one is at 1, 4. So I'm going to go over 1, up 4, about there. Over 2, up 10. So that's going to fall between this 9 and 12, a little bit above the 9. 3 and 12. So exactly right there. The next one is at 4, 18. So we'll call that one exactly right there. The next one is 5, 23. So it's going to be over 5 and just under that 24 mark. Okay. And my last one is at 6, 29, which is going to be just under that 30 mark. Okay. So now what we need to do is draw a trend line. So I'm going to get out my line tool, and I don't want it to be dotted. Okay, so it's going to go from, these are pretty close to a straight line, so I'm just going to estimate this and put it about there. Okay, that line should have, let's see, select. Choose this line, let's make it correct here. Should have arrows on both ends, not just at the end. Oops, that one. Okay, done. Alright, so now what we need to do is to write the equation for the trend line. And we know that we should always be using, whenever we want the equation, we want it to be in y equals mx plus b form. So first thing I'm going to find is I'm going to find my m, and I'm just going to use these 2 points here. They both fall pretty much on that line, and it'll give us a good idea. So I'm going to go with my slope formula, which is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is x1, y1, x2, y2. So I'm going to put 29 minus 4 over 6 minus 1. So 29 minus 4 is 25. 6 minus 1 is 5. So my slope is 5. So I have y equals 5x plus b. And then I'm just going to use this first coordinate, and I'm going to plug it in for x and y to find out what b is. So my y for that first point is 4. has to be equal to my slope of 5 times my x, which is 1, plus b. And then I can just simplify, so 5 times 1 is 5, plus b is equal to 4. Subtract 5 from both sides, and I'm going to get that b is equal to -1. So I know my slope, I know my y-intercept, so my equation would be y equals 5x minus 1. And you can see if my line continued, it looks like it's probably going to hit about there, which would be about -1. So that is the equation of my line, my trend line. This one we're going to skip, but I want you to make sure that you put in your notes example 2 in class tomorrow. That way you and I are both reminded that we need to do it in class, because I want to teach you how to use your graphing calculator to do these, because your graphing calculator will help you find the line of best fit. Okay, so we will do that in class tomorrow. Make sure you make a note of it. This slide is talking about correlation. Okay, it says two sets of data may be related to each other. A correlation is a measure of the strength and direction of association between data sets or variables. When the points tightly cluster in a linear pattern, then the correlation is strong. Data can be positively correlated or negatively correlated. There is a positive correlation when the data values for both variables increase. There is a negative correlation when the data values for one variable increase while the other variable decreases. Okay, so if it is a positive correlation, it looks like they're going up. If it's a negative correlation, it looks like they're going down. If there's no correlation, that means that you couldn't tell, are these going up, are they going down? We can't tell. Okay, so there's no correlation between those. Okay, positive looks like they're going up, negative going down, no correlation, we can't tell whether they're going up or down. So, on example 3, it says identify correlations, state whether it is a positive correlation, a negative correlation, or no correlation. So looking at this one, they've given us the line, which we can immediately say this one's positive. On this one, my x values are going down, and my y values are going up. Okay? So they're going opposite directions, which means that this one's going to be negative. Height and shoe size. Whenever I would do this in class, I would have everyone write down their height on the board and their shoe size next to it, and then we would graph it to see the correlation. And generally what you find is the taller the person, the bigger the shoe they wear. So we would say that this one has a positive correlation because shorter people tend to have smaller feet and taller people tend to have bigger feet. It's not a perfect correlation, but it is in general a positive correlation. Date of birth and shoe size, we would then do the exact same thing, except for we would change it with the date of birth. And what we find is birth has nothing to do with what size your shoe is. So we would say that this one has no correlation. So it says matching situations to scatter plots. Match each situation with the scatter plot that models it best. And we're going to read all three of these before we try and match them, okay? A says number of trucks on the road and number of days in a month. B, time spent driving and distance traveled. C, number of months you own a car and the value of a car. So I want you to pause the video and I want you to try and match them on your own. So pause at this time, please. Alright, so what I do whenever I'm doing something like this is I choose the ones that are most obvious to me and I start there. So let's do that. So the first one that sticks out to me is the number of months you own a car and the value of a car. Most of you are not driving yet, but once you do drive, you will eventually get a car, and you'll notice that what you pay for the car when you first get it and what you sell it for whenever you get rid of it are very different numbers. And the difference is you don't get as much out of the car as you put into the car. So it's worth more whenever you get it, and then it's worth less when you sell it. That would be graph 2. So I know that the number of months you own a car and the value of the car goes with graph 2 because that is a negative correlation. The next one that sticks out to me is time spent driving and distance traveled. Okay, the longer that you're driving, the farther you're going to travel. Okay, so both of those are going up, which means that we have a positive correlation. The number of trucks on the road and the number of days in a month, that has no correlation. It doesn't matter. On any given day, it could depend on lots of different things, like the days of the week, or if there's a holiday, or all sorts of things. So that one is no correlation. So this one was graph 1, and this one was graph 3. Estimations and predictions can be determined when there is a correlation or a trend between data values. Interpolation is a process of determining data points between given data points. Extrapolation is a process of determining data points that are beyond the given data values. And this one is one that we will do in class tomorrow also, and I'm going to have you practice using your graphing calculator to help you figure this out. So, go ahead and make a note that for example 5, we will do it in class also. So that's all I have for you tonight. I hope that you have taken good notes, and I will see you in class tomorrow.